Hi, my name is Jennifer Walls, and I'm here to do a TED Talk on the circulatory system. But instead of calling it a TED Talk, I think we're going to call it a Gen Talk, cue and cheesy music. I know. So what we're going to do is we're going to just start talking about the heart. We're going to start talking about the circulatory system. First, I wanted to reference that I have put in all of my images and where I found all of my images. So I have my pictures of my heart, my pulmonary circulation, my systemic circulation, platelets, red blood cells, and white blood cells. So I use the same images throughout this presentation. So I do give a reference point. So first, we are going to talk about the functions of the circulatory system. The three major functions are going to be transportation, regulation, and protection. So transportation is going to be the self-explanatory one. It provides the blood movement throughout the entire body. The regulation function is basically maintaining the pH levels and balances throughout the body, and protection. So it does provide a defense against any foreign substances, any loss of blood, just anything that would come into the body that is harmful to the body. So what we're going to do, I have my photo of the red blood cells. And I'm probably going to mispronounce the actual proper term, so forgive me. But the red blood cells, otherwise known as the erythrocytics, I totally mispronounced that. Sorry, but it does carry the oxygen and carbon dioxide throughout the body. But there's also what I've learned about the red blood cells is that they are the most numerous, and they are produced in the red marrow of the bones. So now we have our white blood cells, and I will probably massacre this word as well. The white blood cells are known as the leukocytes. What the white blood cells do is they defend the body from all infections. Sometimes they even pass through the capillaries into the tissues in order to help fight any infections in the tissues, which is a process known as diapedias. Yeah? At least I have it written down, so hopefully that's okay. Third, we have the platelets. And what the platelets do is they basically act as a Band-Aid. So what they're going to do, so if any cut or any infections, they're going to go there and they're going to cause the blood to clot. To again form that kind of Band-Aid protection. Lastly, let's talk about the plasma. So the plasma is going to be, I think 97% water. What that is just basically the liquid part of the blood, and it does hold the cells and all the formed elements, and it just keeps it suspended, all those cells suspended. So moving back to the heart. So the heart is going to be the kind of central muscle. To me, it's the most important muscle because it gives us life. So we are going to start with locating the heart. So the heart is located in the trunk region of the body. It is superior to the diaphragm. It's also in a space in between the two lungs, and it's called the mediastinum. But that's basically the space in between your lungs, and that's where the heart is located. Also, the heart is going to be made up of three different tissue layers. The outermost is going to be the epicardium. The middle is the myocardium, and the innermost is going to be the endocardium. So those are going to be your three layers of the muscle. Also, another little thing is your atriums are going to be your entry points, and your ventricles are going to be your exit points. So again, looking at the human body, of course, your right is over here. So we have your right atrium, your right ventricle, your left atrium, and your left ventricle. It's also broken down into two different circulations. So we definitely have our pulmonary circulation. And what that's going to do is it's going to take the blood from the heart, and it's going to go into the lungs. And we're going to talk about all the different valves and arteries and veins in just a minute. But what it does, it takes deoxygenated blood from the heart, gets oxygen from the lungs, and then go ahead and return back. So that's going to be your pulmonary circulation. And then we have your systemic circulation. And what that basically is going to do is it's going to take the oxygenated blood, carry it all throughout the body through arteries, and then it's going to return to the heart in veins with deoxygenated blood to start the process completely over. So you have your arteries, you have your veins, you have your oxygenated blood carrying away from the heart and deoxygenated blood to the heart. And then it starts with the pulmonary circulation, and then it goes into the systemic circulation. So it's just a constant process. So we're going to start with the right atrium, which is basically the end of the systemic circulation. So coming back from the veins, it's going to enter in through the superior and the inferior vena cava. Superior obviously is your top, inferior is the bottom. Your superior vena cava is going to be draining, from the head and the upper extremities, and the inferior is going to be draining from the abdomen and lower extremities. So again, remember, deoxygenated blood is going to be coming in through the right atrium. Again, kind of the end part of the systemic circulation. Also in the right atrium is the coronary sinus, which is located in the back of the heart. So you really can't see it in this picture, but what that basically do is drains the heart muscle. And then we're going to go into the right ventricle, which is considered the beginning of the pulmonary circulation. So we have the deoxygenated blood coming into the right atrium. It's going to flow, and we're going to talk about this valve in just a minute. It's going to flow into the right ventricle. Then the right ventricle is going to be pushing the blood out the pulmonary artery, because artery is away from the heart. So that pulmonary artery is going to be going into the lungs to get that oxygenated blood to come back. So at first it was throwing me off because I was looking at all the pictures that the pulmonary artery is blue, and in my mind I'm thinking that's supposed to be a vein. Vein is, obviously with the deoxygenated, but when you really think about it, that pulmonary artery is carrying deoxygenated blood, and it's carrying it away from it to get to go to the lungs to pull back the oxygenated. So that was always throwing me off. Now it all makes sense. So that's going to be your right ventricle pushing that blood over into the out the pulmonary artery, so we can get oxygenated blood. Then, once all of the oxygenated blood are going to, from the lungs, are going to come and enter the pulmonary veins. So again, it's kind of opposite because the veins are kind of supposed to be blue, but this is all going to the heart and it's oxygenated blood. So they're red, they're coming into the, the pulmonary veins are carrying, and it's going to enter the left atrium. The left atrium is kind of the end of the pulmonary circulation part. So we kind of have the right ventricle beginning, left atrium ending that pulmonary circulation. And that's located right up here. So again, that left atrium is carrying the oxygenated blood from the lungs. Then it's going to move down to the left ventricle. And the left ventricle is the beginning of the systemic circulation. So what then happens is once that blood comes into the left atrium, it goes down into the left ventricle, That left ventricle is so powerful. It is the most powerful chamber in the heart, because there's four chambers. It's gonna, once that contracts, it's gonna push all of that oxygenated blood, and it has to push it because it's going from the top of your head to the bottom of your feet. So it has to really give a good contraction. So it's gonna pump, it's gonna flow all the way through the aorta or ascending aorta, and that's just going to disperse it on where it needs to go and what arteries it's going to be going throughout the body. So that left ventricle is just going to, again, contract. It's going to send all that oxygenated blood. It's going to go throughout the body. When it courses back, it's going to come in through the veins and come in through the superior and inferior vena cava, and again going into the right atrium, hence ending the systemic circulation. So you have your right atrium and your left atrium, and then there's a little wall that's going to be separating those two atriums, and that's actually called the atrial septum. So again, that's going to be the wall separating. And then the little wall that's going to be separating the right and the left ventricle is the ventricular septum, and then the little wall separating the right atrium from the right ventricle is going to be your right atrioventricle septum, and then left wall separating left atrium and left ventricle is going to be your left atrioventricular septum. So you have your septums dividing all the different chambers. Then we're going to have, in those septums are going to be your valves, okay? And the valves are going to be basically working to protect that chamber. So let's go ahead and start here. So we have your pulmonary semilunar valve, and that's actually going to be from the right ventricle going out into the pulmonary artery. In the right ventricular septum, the valve is actually known as a tricuspid. It's known as a tricuspid because basically it has three different parts. It has the dome part, which is of course the starting of the cusp. But then it has these little cordia cordia tendimus, like little fibers. So basically what that's going to do is just going to carry it down, and then they're anchored by the pulmonary muscle. So they're kind of anchored down here. So when that blood flows, what this valve is doing is not allowing it to go back in, like backwards. And then on the other side, on the left atrioventricular septum, is going to be the bicuspid, again, because you have two different parts, or the mitral or the left atrioventricular valve. And it basically works as the exact same as the tricuspid. It just doesn't allow the backflow. We also have the pulmonary semilunar valve that I already just spoke about, and then you have your aortic semilunar valve, and that's going to be kind of right in through here. And basically, because once that left ventricular sends it through the aorta, you don't want that blood coming back. And then the entire process of what the heart's doing is basically called the cardiac cycle. So it begins with these impulses to contract, and it's going to contract by the it's called SA nobe, which stands for sinoatrial nobe, and then that basically continues kind of that contraction wave down until it hits the next phase, which is the AV nome, and that is the atrioventricular nobe. So basically, you have those two nobes kind of working together with the contractions. The contraction phase is called the systole, and then the relaxation phase is the diastole, and that's basically how you get your blood pressure. And also, kind of hidden, the SA nobe, so which is the sinoatrial node, that is actually located in the back wall of the right atrium, which is sometimes called the pacemaker because it kind of starts and it kind of sets the pace of how the heart is going to contract. So that is my Gen talk of the circulatory system. I know I am probably not the best communicator of the saying of the words, but it's starting to make sense. I'm trying so hard to memorize, again, how to say these words. So hopefully by the end of this quarter, they will be in here on how to say it correctly. So my next Gen talk, I'll be using better pronunciations. So hopefully you enjoyed it, and I look forward to this quarter, and I had a great last quarter too. So thank you. Bye-bye.